Hello, everyone. Welcome to ET Manufacturing Industry Dialogue Series. And our guest today is Dr. Dean Bartles, who is the President and CEO of Manufacturing Technology Deployment Group, that is MTDG, a not for profit holding company of the National Center for Defense Manufacturing and Machining and Advanced Manufacturing International. So, Dr. Bartels has earlier worked for General Dynamics Corporation for 30 years, where he was responsible for setting up and running the manufacturing operations in countries like Egypt, Turkey, and the United States. He has served on the board of many prominent manufacturing associations in the US region during his career. So, Dr. Bartels, welcome to the show, and I'm quite excited to interact with you on the various facets of global manufacturing landscape.
Thank you very much. I'm happy to be here.
Sure. So, Dr. Bartels, I would like to start maybe with your career journey. With over 4 decades in the manufacturing and technology leadership, can you share the defining moments of your professional journey that shaped your current role at the Manufacturing Technology Deployment Group?
First of all, I was very, very fortunate very early in my career to get hired right out of college by a major defense company. It was Fairchild Republic Company in my hometown of Hagerstown, Maryland. And they were in the middle of a multi-year contract for manufacturing the A-10 airplane. They made 733 of those planes, and I was hired pretty much right in the middle of that schedule, about aircraft 400 or so. So I cut my teeth in the defense industry the first 5 years there, and then I was recruited by a small company in Pennsylvania called General Defense Corporation. I was hired to be a program manager on a project that they had already started in Egypt, but because of my background in machining, I grew up in my father's machine shop where I learned how to run a CNC lathe and a welding and milling machines, etc. I was the perfect candidate for what they wanted, somebody that had program experience as well as machining experience. So I was sent to Egypt to set up a manufacturing operation there. I did that for a couple of years, and then I went to Turkey and did the same thing. So I'm very, very lucky, really, to have those kind of breaks so early in my career. Eventually, the company that I worked for was acquired by General Dynamics. I moved up in the ranks and took over marketing for a few years, mostly the international marketing side. And then eventually I was given the opportunity to run a business unit that included 3 manufacturing plants. Did that for the last 14 years of my 31 years with the company. And then I got the opportunity to leave a large publicly traded defense company to go to work for a small not-for-profit that just started in Chicago. This is during the time when President Obama decided to set up this Manufacturing USA network. He wanted to do something to help U.S. manufacturing, and he decided that along with his council of advisors on science and technology, that the best thing to do was create this network of these manufacturing innovation institutes. The very first one of those institutes, by the way, was focused on additive manufacturing, 3D printing. It just so happens now that the company I'm running operates that program. It's called America Makes. But the second institute that was formed after that was the Digital Manufacturing and Design Innovation Institute. And I got recruited away from General Dynamics. They made me an offer I couldn't refuse, half the money, twice the hours. But it was a great opportunity. I wanted to do something different. I wanted to give back, right? So to go to work for a not-for-profit that was all focused on maturing advanced manufacturing technology, in this case, digital manufacturing, it was just a great opportunity for me. So I did that for a couple of years. And then after I stood it up and recruited over 300 members, I left there. I helped the Advanced Robotics Institute get off the ground in Pittsburgh. I set up an advanced manufacturing center at the University of New Hampshire. They had received a $5 million gift from a local company and wanted to create this new advanced manufacturing center. I happened to know the chair of the mechanical engineering department. He called me and asked me if I'd come up and do that. So I did that for 14 months. Then I led the National Tooling and Machining Association as their CEO for a brief period. And then finally, the company that I now work for, which was the National Center for Defense Manufacturing Machining. I'd been on their board for about 10 years, small not-for-profit. The other board members asked me if I'd be interested in taking it over, and I did that in 2019. So I'm in basically the 6th year now of running the company. I've grown this small not-for-profit from 27 million in annual sales back in 2019 to over 100 million this past year. So we've grown from about 20 employees up to about 84 employees now. Most of our work is in this advanced manufacturing space. So I've been very, very fortunate along my career to have these kinds of opportunities.
That's great. Fantastic journey. You have huge experience and exposure to the manufacturing industry, I can say. So, looking at that or considering that, how would you describe this current state of the global manufacturing landscape? Are we in a period of transformation or redefinition?
Yeah, I would say we're in a period of transformation. So, digital manufacturing really is synonymous to this Industry 4.0 as a term that the Germans coined. But it's all about, data, right? They say data is the new oil, but putting sensors on machine tools, even old legacy machine tools, outfitting them with sensors, collecting real-time in-process data as things are being made, whether it's subtractive or additive or process, whatever, and then being able to mine that data to figure out more efficient ways of doing things. And then along comes AI, right? So AI has just exploded. It's definitely affecting advanced manufacturing in a huge way. So now that we're able to get all this data off the machines because of the implementation of the digital technologies, now to have the AI tool available to mine that data even more, I definitely think we're in a transformation stage, and it's going to continue to transform over the next several years.
So, do you think this is the great transformation which the manufacturing industry is undergoing, considering the first industry revolution, second, third, and fourth? So, how do you describe it? How the industry has evolved over the years?
So certainly, this phase that we're in now, that I personally still think is Industry 4.0 phase. It's all about the data, and AI is just one new tool that we're able to use to mine the data. But this is a phase where automation is huge. We've got this concept called the Internet of Things, where we're adding these IoT edge devices to machines that to be able to get data off of those machines. There's a new era of transparency in the supply chain. I can remember when I ran several plants for General Dynamics, it was very frustrating when you're trying to get parts all shipped around the same time to the final assembly plant, and you find out that one of your suppliers has lied to you, and everything else is there waiting to be assembled, but you can't assemble it until you get this final order of parts. Very, very frustrating. So now with the transparency that the IoT devices afford a manufacturer, you can know where your parts are in your supply chain real time, every day, every hour of the day. And not only can you know where your parts are, but you can also know an awful lot about those parts before they ever get shipped. For example, I can remember one of the product lines that I made for General Dynamics. It had, let's say that just the one component had 13 dedicated machines from operation 0100 to operation 1300. And as those parts move from one machine to the next, now with the transparency that we're afforded, you can know exactly the quality of each one of those operations as the parts move from machine to machine. So, as everyone knows, machines incur something we call drift, and they begin to slip a little bit. Um, Now, with the technology available, you can know any parts coming off of operation, let's say 0400, that may have experienced a little drift. Well, the machine that's going to do operation 0500 knows that drift and knows what to do to compensate for it. So, you can know everything about those parts as they're being produced, as they're moving down the line, and before they ever get packaged to be shipped to your final assembly plant, you know exactly what the quality of those parts are. So that's a huge movement forward in this transformation that we're experiencing.
As you are aware, this global supply chains have faced severe disruption in the recent years. If you consider from pandemics to now the geopolitical conflicts. So, what short-term and long-term impacts are you observing on the global manufacturing ecosystem?
I'm sure your viewers have read as much as the rest of us have about the concept of nearshoring, reshoring, friendly shoring, whatever term you want to use. But more and more companies are starting to figure out, you know what, maybe we should keep our supply chains a little more local and not be so dispersed all over the world, because some countries react differently to these kinds of issues, right? So certainly the pandemic was a big wake-up call for lots of companies to say, okay, even though it might be cheaper from a labor perspective to manufacture some of our parts in certain parts of the world, if you can't get those parts because of, they shut down their plants, in some places they shut down the whole country, that's a problem, right? So now everyone's taking a very hard look. Of course, here in the United States, we have a current president who wants to bring as much manufacturing back to the United States as possible. So he's introducing a significant amount of incentives to do that. So I think part of this whole digital transformation phase that we're experiencing, we're also experiencing this concept of reshoring, bringing manufacturing back more locally, and it's not just in the United States. Other countries are doing the same thing. So that's going to be a big movement, and I think you're going to see a lot more of it going forward.
So when like you aware that United States president have he wants to bring back the manufacturing in the country. But considering the labor cost or the production cost, and of course the raw material or other components which currently it's imported in the United States. So what are your views on that? Going forward, what can we see in this manufacturing?
So it's going to be a little painful for the American consumer. We're going to have to pay higher prices for a while, but I think that the new technologies that are being brought to bear are going to make manufacturing in this country, as well as many other countries, a lot more efficient. We're going to have to figure out ways to do things with less people because we know there's skilled labor is becoming more and more scarce. Um, there is a big push here in the United States to try to get more people to go into the trades. Even our current president, you may have seen in the news, he recently said he wants to take a couple of $1 billion that Harvard University gets and gives it to the trade schools. I think you're going to see more focus of more money going to the trades for to trying to train up the next generation workforce. For many, many years, people considered manufacturing dumb, dark, dirty, and dangerous. But now manufacturing is not that way. It's very modern, it's very clean, it's certainly not dangerous, and it's very high tech. So automation plays a key role in this. But I don't see automation and robotics eliminating jobs. I see it filling the jobs that we can't find people to do. So automation with robotics and with IoT edge devices, et cetera, is going to play a big role as we begin to manufacture more and more in this country, as well as other countries begin to manufacture more and more locally.
So how can the global manufacturers strategically plan for the future of supply chains while navigating the ongoing this geopolitical uncertainties and also the trade wars? What would be your advice?
Yeah, I think companies need to shrink their supply chain footprint, and I think they need to require their suppliers to afford them the level of transparency that I described earlier. I have been pushing this issue myself for a couple of years now. I know there are companies out there that are resisting. I've actually had vice presidents of supply chains and large corporations tell me they will never give their customers that level of transparency. And I'd simply tell them, you're going to find yourself sitting out in the future because the primes are going to require that kind of transparency so that they can have better control of their supply chains. But you're going to see more and more of that supply chain be brought back locally, no matter what country you're talking about. So you're going to have to plan for that. It's going to take time. It's not going to happen overnight. It's probably going to, take at least 5 years, maybe 10. But you're going to see more and more manufacturing be brought back locally in countries because we can't afford another episode like we had with the pandemic.
You mentioned about this advanced manufacturing technologies or maybe digitalization and technologies like AI and Industry 4.0, which are like dominating the manufacturing industry globally. But if you see, yet the many small and mid-sized enterprises, they struggle with the adoption of these technologies. So what are the biggest roadblocks you see which SMEs face, and how can these be overcome?
I think the biggest roadblock that SMEs face is they simply don't have the time nor the staff to explore these new technologies. Most of the manufacturers in the United States are small manufacturers, less than 500 people. In fact, I think it's over 95% of manufacturing companies are considered small mediums, right? And of those, the significant percentage are really small, maybe 20 employees or less. And people that own and run those companies, I mean, it's all they can do just to get their products out the door to meet their customer demands. They don't have time to begin exploring some of these newer technologies. So it's going to take some time. Now, what we're trying to do with Advanced Manufacturing International, a subsidiary that I created, whose intention and their focus is to help community colleges that offer 2-year degrees train them up on these newer technologies. That way, when they get hired by these small medium companies, they will be bringing in people that know something about these technologies. And as you know, any new employee wants to always impress their new boss. So for them to say, listen, for like $3,000, I can add this IoT edge device to this old machine you have here, and I can begin to see data real time on the process as they're making parts. It's not going to hurt our production. In fact, once I have this data, and once we, let the AI people loose on it, we're going to be able to figure things out how we can do things more efficiently, i.e., reduce cycle times, i.e., reduce the amount of material being used, basically save you money. Well, who wouldn't want to hear that? But the currently the people that are running these companies, they're like a one-armed paper hanger. They're so busy trying to do everything themselves, whether it's meeting the payroll or even cleaning the bathroom at the end of the day. I mean, they got to fix the printer jam. They got to do everything, right? So I think what eventually, as they grow a little bit, they're going to hire some of these younger people. We got to get these younger people trained up with these skills. That's all there is to it, because the people that are already working out there, they simply don't have the time. And trying to justify a purchase of a new machine, it's always difficult to calculate that return on investment. And are you going to get that thing paid for in 2 years? A lot of large corporations require that kind of a short-term payback period. So that's difficult for small mediums. But I think over time, as their workforce begins to become a little younger, and they will, because as you know, we're experiencing the big silver tsunami now, where so many people are retiring. They're going to have to hire younger people, and as they bring some of these younger people in, my goal and the goal of many other associations is to train up these younger people with the skills they're going to need to take that manufacturing to the next level.
I think with this kind of scenario and this is roadblocks, if they consider, they will definitely, it will take, of course, as you said, it will take some time, but they will definitely overcome these kind of challenges. But uh, how is the scenario in the manufacturing industry overall in the US region in terms of attracting the talent or young talent to the manufacturing industry?
I've seen some very, very encouraging news lately. For example, the enrollment in trade schools is up almost 20% in the last year from what it was the year before. Over the last couple of years, it's even higher percentage wise. I think with the focus that the current president is putting on this, I think you're going to see that continue to grow. So some very encouraging signs that the younger people are starting to realize, you know what, is there a better alternative than going into debt to the tune of a couple $100,000 to get a 4-year degree that I'm really not sure I'm going to be able to make that much money and ever be able to pay all that money back? Well, for example, I'll give you another great example. In Colorado, they just passed a law where the public high schools, okay, not community colleges, high schools, can now graduate regular 4-year high school program, can graduate students with a 2-year associate's degree in the trades. That's huge. And I think you're going to see more and more states adopt that philosophy, because it is a big problem. Every state needs more people to fill these jobs. So even, the trade school enrollment is up. The states are trying to do something pretty innovative and figuring out how they can have the high school. When I went to high school, even junior high school, back, this is 50 years ago, but I had to take, machining and woodworking and carpentry and welding and all those things in 7th and 8th grade. And over the years, they did away with that in the public school system. I'm starting to see it all come back now. And I'm glad that it is, because there's great jobs out there. It's a great way to, for people to have a career and to make a mid-level income, be able to raise a family, afford a house. So I think you're going to see more and more focus on that and less focus on going to colleges.
Right. We have almost a similar scenario in India as well, that attracting the young talents to the manufacturing industry has always been a challenge to the manufacturers. And I'm sure the government in India, as well as the academics, they are playing a major role in improving this situation. So, what does the true leadership mean to you in 2025 and beyond, especially in this manufacturing sector, which is facing the rapid disruption and the transformation?
I think it's critical that the leaders of these companies stay abreast of this ever changing, very rapidly changing environment that we find ourselves in with manufacturing. There is stuff changing so frequently. And for the leadership to be able to take advantage of these newer technologies, they're going to have to invest some of their own time outside of the normal working hours to stay abreast of these technologies. I've always said, if you're in sales, there's a famous term. Everyone says ABC, right? Always be closing. Well, what I say is, as a very senior leader, right? I still say ABL, always be learning. You have to stay abreast of these technologies. I mean, take additive manufacturing, for example. I mean, 10 years ago, I didn't know anything about additive manufacturing. Then all of a sudden, 6 years ago, I find myself running a company that actually runs the Additive Manufacturing Innovation Institute in the United States. So I took it upon myself to, outside of normal working hours, to begin reading and learning and taking, online courses to figure out what the heck is this additive manufacturing. I've learned so much about things like laser powder bed fusion. I mean, who would have ever heard of that term before, right? So you've got polymers, you've got metals, and I used to think of additive 3D printing, right? I used to think of that, well, that's just to make toys or maybe for an engineer to have a prototype they can hold in their hand. No, no, no. It's advanced so rapidly, and now you're seeing, metal additive manufacturing parts going into jet engines, going into all kinds of platforms. So that's just one technology. You've also got the IoT edge devices, you've got the robotics, you've got the AR, VR. You're going to have to stay abreast as a leader of these technologies to be able to train up your workforce and encourage them to stay abreast of these technologies. And it's in my opinion, it's got to start at the top. You have to take it upon yourself to find out what these technologies are and how can they be deployed in your manufacturing operation.
Yeah, perfect. As you rightly said, whether you are a leader or the part of the workforce, the learning shouldn't stop. It is like
Yeah,
forever, right?
absolutely. Absolutely. ABL, always be learning.
Yeah, I like that. How can manufacturers balance the need for rapid technological integration with cybersecurity and at the same time the workforce readiness in this highly connected digital environment? How do you balance that?
Very, very difficult to balance, but very, very important that you do. In the United States, if you are a defense contractor, and when I say a defense contractor, I don't mean just the big primes like Lockheed Martin and Raytheon and General Dynamics. If you are a tier one, two, three, four, five supplier, and you're making something that eventually is going to go into a Department of Defense product, you have to become CMMC certified, Cyber Secure Maturity Model Certification. The DoD has rolled that out. It's here now. And you have to make sure that your people are trained. You have to make sure that your equipment is cyber secure. So it's a very, very big push. And even though that's only for if you're doing business with the Department of Defense. But guess what? All the commercial companies are facing the same kinds of challenges with all the ransomware attacks that manufacturing has experienced. So everyone's going to have to become much more fluent in the cybersecurity aspects of their operations. And I don't mean just the computers. It's also the machine tools. If your machine tools on your shop floor are connected to the internet, you're going to have to make sure you've got the right cybersecurity measures in place to ensure that no one is hacking your machine tools. Let me give you one example real quick. There's a professor friend I have at Virginia Tech who, for his class, he had them write a small program to 3D print a part. He had them turn their programs in on little jump drives. Well, what he did, he said he was just going to use the jump drives to review their programs and grade them. But what he did is he added a couple lines of code and then he gave the jump drives back and said, okay, go make your parts. Well, when they printed those parts, his extra couple lines of code introduced a defect in the part that you couldn't detect when the part was being made. And then when they ran and made their parts, guess what? The parts failed. What does that tell you? If your 3D printer is connected to the internet and a hacker can get into that 3D printer, they can introduce defects into your parts without you knowing it. There was only one student in the class that caught it, and he only caught it because he watched his machine print the part the entire time, and he noticed something funny happened that he wasn't expecting. But all the other students didn't, they had no idea. So it's kind of scary what these hackers can do with if they've got access to your machine tools. So yeah, cybersecurity is huge. It's becoming more and more important. And if you, like I said, if you're doing business with the Department of Defense, even as a tier 5 supplier, you're going to have to get CMMC certified.
Can you tell us more about MTDG? What kind of activities and initiatives currently your organization is into?
So our focus is primarily with the Department of Defense. So we are very close with our customers in the Department of Defense, and we learn about challenges that they have with maybe the design of a platform or the making of a platform. And what we do through our alliance partner network is we find companies that we think can bring a solution to those problems. And then we go with our partners to the DoD customer and explain, look, this is what we can do to help you. That's proven to be a very successful model. In fact, oftentimes the program managers in the Department of Defense will call us now and say, hey, we've got a problem and we think you can help us. What we do is we work all these problems through our alliance partners. So MTDG and primarily NCDMM, we don't own any IP. In fact, we pride ourselves on not owning any IP. We always want to be the neutral convener, the honest broker, if you will. We want to partner with companies that do have IP. We want to help them get their contracts with the Department of Defense. So our expertise is we know federal government contracting inside and out. We know federal government accounting inside and out. So a lot of small mediums that have really cool niche technologies, they don't have that knowledge. So we make a great partnership. So we become the prime contractor and we manage the accounting side and the contract terms and conditions side, and we have a program manager assigned to every project. But the actual technology that gets deployed comes from our alliance partners. So we've got a very extensive alliance partner network. We are constantly scanning the environment to find new companies that have new technologies that we think can be brought to bear to solve a problem for the warfighter. And we partner with those companies and take those technologies to the marketplace.
So I will just come to the last question. As someone deeply involved in both the defense and advanced manufacturing technologies, so what excites you the most about the next decade of manufacturing? And what message would you like to give to the next generation of manufacturing leaders?
Yeah, I got to tell you, the whole AI thing is so incredibly exciting. Let me give you an example. Additive manufacturing's been around for more than 25 years. It's come a long way. It still has a long way to go. Laser powder bed fusion, I'm not sure if your listeners are fluent with that technology, but basically you've got a machine that's got a bed, a table, if you will, inside of a chamber. It spreads a thin layer of metal dust and a laser hits it with a specific pattern. And then the table lowers a little tiny bit and another layer is spread and the laser hits that layer. And that process continues and repeats itself for, I don't know, 1,000 times or more until the parts build up literally from the ground up. Well, sometimes that laser interacting with that metal dust, you have little tiny problems that happen. Well, AI technology can be brought to bear to be able to take a scanned image of each layer and let the AI determine whether or not there's something wrong with that layer. And if there is, can you then, through the deployment of adaptive control, can you then go back and do something to fix that layer before the next layer is welded, if you will? So AI is so exciting. I heard recently of a study that was done where they took CT scans, basically from breast cancer patients. Okay, that they knew these were like 25-year-old scans, right? And they knew which patients over those years developed breast cancer that unfortunately was perhaps diagnosed too late. They ran those scans through AI, and the AI was able to pick up the anomalies that eventually led to the breast cancer where the doctors never saw it. Think about that same technology now in this laser powder bed fusion, where you're taking a scan of each layer, and every AI image of those scans is going to be able to discern whether or not you've got a keyhole formation, whether you've got spatter from the powder being injected around too fast. There's so much that the AI is going to be able to pick up. Now we've got a long way to go before we get there, but I really think that it's going to have a huge impact on these new manufacturing processes. So I'm very excited about it. I'm trying to learn as much as I can about it.
That's great. It was really fantastic talking to you, Dr. Bartles, and I'm really happy that you touched upon lots of areas of manufacturing. We probably any manufacturing in any country would like to know, be it like leadership in this digital area, the workforce training, as well as the problems the small and medium scale companies face in terms of the digital adoption, and of course the next what we can expect in the next few years. So great interacting with you, and thanks for coming to our show.
Well,
And I look forward to interacting with you again.
and let me also say thank you for letting some of your really smart people come over here to the United States, because I can tell you, I attend a lot of academic symposiums, and so many of the really, really smart researchers in manufacturing come from India. And they are doing fantastic research here in the United States that's pushing this technology forward. So I want to thank you too.